So in the previous video, we went and set up a RSA public key cryptographic system. Our two prime numbers were 31 and 29, giving a product n of 899. We had a d and a e, respectively 11, and we calculated the e to be 611. So that gave us a public key of n and 611, and a private key of 899 and 11. Being our n. So now let's go and use this system to encrypt or decrypt a message. Okay, so let's just copy that over here. We had the public key was 899 and 611, and the private key was 899 and 11. So suppose we want to go and decrypt the message 25. I am the holder of the public key. I receive an encrypted message. Its numerical representation is 25. I want to go and decrypt it. So what I do is I apply my private key to 25. Now remember what I need to do. I take my private key, I take whatever is the input, I put it to the power d over there, and then I take the remainder after division by 899. Alright, now if you go and punch 25 to the power 11 in your calculator, you get something enormous. And it's not, unless your calculator has a mod function, you're going to have some trouble calculating this directly like this. If you were to go and punch it into the calculator on your computer, into your Windows calculator, you could do 25 to the power 11 and punch mod 899, and it should give you an answer of 749. Now if you don't have that at your disposal, you need to use your pocket calculator and some facts about congruences, which you know, in order to whittle this thing down to something that you can actually manage with your pocket calculator. So what I'm going to do is I'm going to say, well, let's look at a smaller power of 25, which we can handle. So you can try a few powers. Let's try 25 to the power 5. That might be something more manageable. So if I take that, 25 to the power 5, okay, that looks a bit more manageable. So what am I interested in? I'm interested in the remainder after division by 899. So I say 25 to the power 5 divided by 899. Okay, so 899 goes in 10,862 and sometimes. So many whole times it goes in. So I can rewrite 825 to the 5 as 10,862 times 899 plus, and what's the remainder? So I'm going to say 25 to the power 5 minus 10,862 times 899 gives me 687. Now there's a little check that you can perform here all the time, because what you get here, the intention is that this must be a remainder after division by whatever you're dividing by, in this case 899. So firstly it needs to be non-negative, it can be 0 or larger, but also it needs to be strictly less than what you're dividing by, in this case strictly less than 899. If you get something else there, you've made a mistake, because this needs to be a remainder. Okay, how do I use this fact now? Okay, I say, well, I can go and rewrite 25 as 20 to the power 11 as 25 to the power 5 all to the power 2. That gives me 25 to the power 10, and then I must multiply with another 25. So using laws of exponents, all of this is again going to give me 25 to the 11. So all that I did is I rewrote 25 to the 11 in terms of 25 to the 5. Right? I'm still interested in calculating the remainder of this after division by 899. Now, this guy leaves a remainder of 687 after division by 899. So by laws of congruences, I can go and replace this 25 to the 5 with 687, and the remainder after division by 899 will be the same. This guy and that guy, this guy and that guy are congruent modulo 899. That means they leave the same remainder after division by 99. And laws of congruences tell me I can replace in powers and in products congruence with congruence, and the result will be congruent. So I can replace 25 to the 5 with 687. Right. So this is a somewhat smaller. It's something I'm more likely to be able to handle. So let's go and look at 687 to the power 2. So 687 to the power 2 is equal to that. We can handle that. Okay, so let's divide that by 899. So 899 goes in 524 times. So I can say 687 squared is equal to 524 times 899. And what's the remainder? So I say 687 squared minus 524 times 899. It gives me 893. And yes, 893 is non-negative and it is smaller than 899. So it seems that I didn't make a mistake. So this means, again by the same argumentation before, I can replace 687 squared with 893 in this thing, and the result will leave the same remainder after division by 899. So 893 times 25, remainder 899. Okay, so let's see if we can calculate this. So 893 times 25 is 22,325. Alright, let's see, I want the remainder of this number after division by 899. So let's divide it by 899. 899 goes in 24 times. So 22,325 is equal to 24 times 899. What's the remainder? So I say 22,325 minus 24 times 899 gives me 749. So this thing is equal to 749, the remainder of that after division by 899, but this is a non-negative number, strictly smaller than 899, so if I go and divide it by 899, all that I'm going to get is the number itself back. So the answer is 749. So I've decrypted the received message 25, and the result is 749. So if this had been encrypted with my public key, I've now applied the private key, so this should have been the original message sent.